In this video, we are going to be learning how to solve problem that deals with what? Mass volume relationship or stoichiometry of chemical reaction. Now, what you are going to learn in this video will show you how you can calculate from what? Mass to volume. That is when you're given a mass and you are required to get the what? The volume of the product or the reactant, the volume that will react. And again, another one you're going to be learning here is how to calculate when you are given mass and you want to get the mole of a certain product or reactant, as the case may be, and then you are going to be seeing how you can use the stoichiometry relationship or mass volume relationship to calculate, to find the mass of to calculate the mass of the reactant and the mass of the product. So at the end of this class, you notice that these calculations are not something, they are not a kind of scary, or there's something exciting. They are very, very exciting and easy to learn. So join us as we go through these example questions we are going to be using to show you how to do this thing clearly. All right, let's go with the first question. The first question says that what volume of carbon 4 oxide is produced from 20 grams of carbon at STP? Now, this is a very interesting question. Now we're going to be calculating. This one has to do with what? Mass. Mass to what? Volume. This is mass given to us, and we need the volume of this. So before you do this, in that basic thing you need to do before you solve this problem, the first thing you're going to be doing here is to what? Write a balanced chemical equation. Get a balanced chemical equation. The first thing we do, we know that carbon will react with oxygen to give us carbon 4. So what do we have here? Carbon combined with oxygen to get what? Carbon 4. This is the reaction. From this reaction, they have a stoichiometric ratio. We're looking at the stoichiometric ratio, and also we can also be seeing every relationship that exists here. From the relationship, we'll find out, look at one of the things you can get in a balanced chemical equation. One of the things is the ratio, the mole ratio of the reaction, and then you can also get what? The mass of the reactant and the product. In this case, we are given a mass, and then we need to find a volume. Now, for every gas at STP, at STP, all the gases have a molar volume of what? 22.4 gm3 or liters. 22.4 gm3. That means at this in this balanced chemical equation, the volume of carbon 4 that will be produced will be what? 22.4 gm3. Note it very well. Now, that is so if 12 grams of carbon will combine with what? This is 16 times 2. 16 times 2 will give us, it should be 32. Let me just give us 32. Yes, I think it's 32. This calculator does not really want to work. 32. That means 16 and 32. So, mean that now from this balanced chemical equation, these are some of the things you need to know. If 12 grams of this will bond with 2 grams of oxygen, it will give us 22 gm3 of what? Carbon 4. 22.4 gm3 of carbon 4. This is from this balanced chemical equation. Some of the information you can get there. This one of the information, this and that and that. These are information you can get from there. Now we are looking for what? Mass volume of carbon 4 that will produce. If 12 grams, now you say, if 12 grams of what? 12 grams of carbon 4, 12 grams of carbon will give us 22 gm3 of what? Carbon 4. That is what it will give us. Now, what will this one be? 20 grams will then be equal to 22.4 over 12 times 20 over 1. So let's look at his user. So if we are, let's just use our calculator. From calculators, we can see that 22.4 times 20 divided by 12. So what we have here is we have 37.3 GM cube. That is what we have here. Now note how we are able to get this thing done by comparing them. Since 12 grams will give us 22 grams, 22.4 GM cube, then we're able to get this one. This one, like I told you, is mass to volume relationship, mass to volume stoichiometry. So we're going to be dealing with the second question. The second question said, how many moles of hydrochloric acid are needed to react with 4.8 grams of magnesium? This is now we are moving from what mass to what moles. Like I said before, you need to get a balanced chemical equation. This is magnesium reacting with hydrochloric acid to give us magnesium chloride and then hydrogen. Then we'll have this here. So from this balanced chemical equation, now we are dealing with mass to mole. Now here we have 24. Remember, the molar mass of magnesium is 24. So we say 24 grams, and then here we have 2 moles because we are dealing with moles now. That's one of the ways to make it easier and fast for you. So since this is what we're looking for, it means that 24 grams of magnesium will need what? Will give us 2 moles of what? Hydrochloric acid. That's what it will require. So then we have 4.8 grams of magnesium. What we have here will be 2 over 24 and 4.8 over 1. So we have 2 times 4.8 divided by 24. So what we have here will be what? It will be 0.4 moles. Mole of what? Hydrochloric acid. Say how many moles of hydrochloric acid? So what we have is 0.4 mole of hydrochloric acid. This is for what? For what? Mass to what? Mole. So the last one we have here deals with what? Mass to mass. In the question it said, what mass of sodium chloride is produced from 9.8 grams of sodium? What mass of, see that, coming from one mass to another mass of the reactant, giving us, this other one is giving us mass mole of the what? The 2 reactants. This other one is giving us mass of a reactant, giving us and the to what? Mass of the product. This other one is giving us mass of the product of the reactant to what? Volume of the product, which is carbon 4. You just see the way it moves. So the next one we're doing, let's handle this other one. Now, from a balanced chemical equation again, we know that this will react to give us sodium. Yeah, that's what will get sodium chloride. From the equation, we find out that they are what? 111, the moles. Now, based on what we want, because we are looking for mass now, we can just skip this mole. We have sodium is 23, we can say 23 grams, and then sodium chloride will be what? 23 plus 35.5, we will have 58.5. That means here will be 58.5. Perhaps if you are wondering how I managed to get this in, you look at their relative atomic mass. This one is 23, this other one, chlorine, is what? 35.5, while sodium is 23. So in a case like this, you can also see it as what? Their grams in the molar mass. So the gram per mole for 1 mole of this contains this, because it's gram per mole. For 1 mole of sodium contains 23. 1 mole of sodium chloride we have this since it's gram per mole. So here, so we have been able to get this thing done. What we have here from this balanced chemical equation, what we have 23 will give us 58.5. Now this said 23 grams, 23 grams of what? Sodium will give us 58.5 grams of what? Sodium chloride. Now we'll go to what we have. Sodium, we're looking for 29.2 grams of what? Sodium will then give us we have 58.5 over what? 23 times 9.2. So we have 0.5 times 9.2 divided by 23. So what we have here, what our final answer will be, is equal to 23.4 grams of what? Sodium chloride. So this is where we're going to be ending the class, and I hope you have learned something. Thank you so much for being part of the class. For me, I will leave a question in the comment section. I will leave a pin question in the comment section there. You can use it to test yourself and know your ability of solving this. Perhaps if you have any issue on it, you can always come back to the video and see how you can work on it. Thank you so much for being part of the class, and I would like to read your comments. Make sure you share and like, and if you have any question, leave it in the comment section. And if you are joining for the first time, don't miss subscribing for us. Make sure you subscribe to our channel, and that's one of the ways you can encourage us. Thank you.